Hello, everyone. As we said, we'll be starting in a couple of minutes, just giving the time to everyone to connect. Hello, hi Eric. So yeah, we are about to start in just maybe around a minute or so. Um, we start typically 5 minutes past the hour. So it's not you that. Yes, thank you for being here. No, the room is silent. So just we're starting in a minute. So Pascal, can you give me the hand, please? So this way I can change my slide on my own. Thank you very much. So it's 5 minutes past the hour. So we'll get started. Hello, everyone. So this is an interim meeting of the SCHC working group. It is the first after the after IETF and 120 in Vancouver, and I hope you've spent a good summer. So we're starting with the note well. So as a reminder, so this is an official IETF meeting, and as such, all policies of the IETF apply. So this is the note well. This is only a summary, so please go and read all the documents that are listed here. So by participating, you agree to follow IETF process and policies. If you're aware that any IETF contribution is covered by patents or patent applications that are owned or controlled by you or your sponsor, you must disclose that fact or not participate in the discussion. And so there are lots of other information, but one that's really important is, as a participant or attendee, you agree to work respectfully with other participants. And here you have, of course, the BCP 25 for anti-harassment procedures. But in any case, and the code of conduct, BCP 54. In any case, please read all the documents that are listed here. So we'll start with the agenda bashing. So this is the agenda for today. We've already put a couple of minor changes compared to the agenda that was published earlier. The first one is that the presentation on the deep space buff and chic. So we have Marc Blanchet with us, who is one of the proponents of the buff, and he'll be talking together with Laurent about what's going on there. So thank you, Marc, for being available under such a short notice. So that's the first minor, and there is a little bit more time for that slot. So that's the first change, and I think this is the only, and then again, times was adjusted because of that. Does anyone want to change or propose any, do you have any comments on the agenda? I'm hearing nothing, so then let's move on with this agenda. So the first thing in our general administrative part, on the administrative part, we will be requesting a slot for the IETF 121 in Dublin. The last IETF, we had a 2-hour slot, and we actually managed to fill this one, and we're quite tight in it. We will have more discussions and more further discussions on a lot of the ongoing documents. So we think that 2 hours is a good slot for us, and we'll be requesting that. Do you have any opinion on that? Any thoughts? So in case you feel that, okay, so we have we have 2 comments from Laurent and Carlos that are +1 on this, agree on that. So we'll request that slot, and Anna as well. And of course, we'll be listing the usual working groups that we would like to avoid conflict with. In case you feel there are additional working groups that we need to include in that list, please send a mail to or chat to the chairs. And we'll have a couple of interim meetings. So we're starting our regular meetings every 2 weeks, and we'll have the penultimate interim on October 15th, which is a little bit before the draft submission cutoff deadline. So that's pretty good. And then the last interim that we have is right after, on October 29. So we'll see the topics that we'll be discussing there. And I'd like to benefit from the remaining 1.5 minutes, 2 minutes, just to go over the different documents, the working group document status. So Pascal is going to be talking about protocol numbers. So we're not going to be discussing this here now. I mean, he's going to talk about this right after. So we have the SCHC over networks prone to disruptions. That was submitted as a working group document. So thanks to the authors about this. We had the last call and the adoption at the past IETF and on the mailing list. So that's great as it is with the new name. Thanks to the authors. So that's the first thing, and then we have the working group, the work going on the RFC 8824 update this. So that work is ongoing. In, Marco, do you want to say anything about that, or just work is ongoing? Not or nothing specific. Maybe nothing specific. I mean, just ongoing. Okay, thank you. So that's good. So that's just ongoing. So that's really well. The SCHC architecture. So we'll be saying a couple of words at the end of this meeting. So work is ongoing as well. Pretty good. I'd like to ask if there are any news about the SCHC OAM document or the SCHC FEC document, because they were related. Yes, Laurent?
So for OAM, I think we're ready. So I don't remember if we had to make another working group adoption or. But for me, the document is stable, or at least wait for comments.
Okay. Yes, and you did you did remove the part with the actions from it, right? This one is
Yes,
the
it has been. So there was a lot of mistake in the previous one and the example. So we correct at least the one we saw, and we remove the action part.
Okay. Okay. So I think just to make things simple, we're going to start then a working group adoption call for adoption. Because I mean these were like we discussed all these documents a couple of times, so I'm going to send this to the mailing list, and in 2 weeks, depending on the results, we will adopt the documents or continue the call. Okay, thank you, Laurent. Anything about the FEC? Does anyone have any? Because it's an item that's important. I mean, we have it in our charter, so I'm going to see with the authors how are things going. Okay. Well, with this, I suggest that we end this part. We can discuss the access control part and the PPP part on our next interims. So thank you, and I'm handing. So Pascal, you can. You are next on in the. You're next on the agenda with the presentation. So some ideas you had on SCHC over network prone to disruptions and proxies.
Hello, Alex. Hello, all. Yes, we had some discussions about this new draft that was adopted. Let me switch on the video. I don't have a slide for this discussion. Yes, the discussion we had is there is an interesting topic that is created or introduced by this document that was just adopted and published as a draft IETF SCHC. And this concept is the concept of a proxy. If you look at it, the SCHC gateway is a form of proxy, but not a layer 4 proxy as we're used to. In this case, in this draft, the proxy that's being described is more of a usual proxy that quote unquote terminates a transport and starts a new transport on the other side. So acts over layer 4. And well, I thought it was an interesting topic that is just not discussed or addressed in the architecture. And well, I wanted to have this discussion with you guys, and maybe we'll talk more at the IETF during the meeting in Dublin. How and if we want to introduce the concept of a proxy, and what role does it play, and do we consider the SCHC gateway as a proxy, or is it a different beast, or do we proxy only above transport, or can we proxy at every level, or is the proxy a SCHC gateway at layer 4? I mean, how do we position what we used to call a gateway and the SCHC proxy? The SCHC proxy in this document, basically what it does is terminate fragmentation, which can take a long time if you go over DTN or very interstellar, at least a space network that can take very long between packets or between frames. And for a frame to go from point A to point B, we would basically terminate that quote-unquote transport that would be based on the SCHC fragmentation. And then on the other side, act as a normal proxy, so convert CoAP maybe onto HTTP and move on with HTTP over IP on the normal side. And I see Alex is on the queue. Alex, I just finished my sentence and I'm with you. So well, certainly this concept is usually interesting, and the question is really raise awareness about it and discuss how we place it in the architecture. And Alex, with you. Alex? Why?
Yes, I forgot. So let me turn on the camera as well. So yeah, thank you. So you mentioned fragmentation. Maybe also the question is about compression. Is the question about proxy only about fragmentation, or does it also, can it also be used on compression?
Yes, the usual gateway, yes, was for compression to start with. And fragmentation was only when the packet was too big, which was not necessarily the case. So yes, obviously that's when I spoke about CoAP. I mean, the idea is you would do fragmentation and use the fragments to ensure something reliable over DTN types of networks. And at the same time, carry CoAP as a compressed packet. So you can use very low power radios, blah, blah, blah. And then on the other side, appear like a normal internet proxy, so like a client real.
Okay, so one thing I was thinking about when you mentioned proxies, and thank you for actually bringing this discussion. And I mean, not that there is nothing written yet.
In the architecture, certainly not. In this document, yes, the functionality is quite described. They don't talk about COAPs, mostly the transport piece, which is interesting. But really, the intention is, as you say, to proxy for everything, and possibly also translate the CoAP into HTTP, which is what CoAP people do.
So one thing, and I see also Laurent joining the queue. So I'll ask the question, and then I'll cut. At some point we were doing TCP on one side. So we did a proxy that on one side had TCP, on the other side had an LPWAN connection. So we had SCHC going ensuring the other side. So basically we had two proxies with two TCP connections on both ends, and you know, like the proxies were keeping the TCP connections a lot.
Yes, so really proxying, translating at layer 4.
Yes. So what do you have in mind here, and what's in the discussion? Can we use SCHC in this aspect to proxy the internet protocols to some other protocols where timing is different?
Yeah, I mean that's the story, right? That's what is being said here. But as you said, I mean, we would do the whole SCHC and probably appear to the internet not only as a layer 4 translation or adaptation, but also layer 5, like CoAP to HTTP and whatever application base. But yes, I mean, that's why I was talking about the gateway. The gateway is the beginning of that, operating typically at layer 3. But you describe operates at layer 4, an HTTP proxy like looks at HTTP. So if you place HTTP at layer 4, then still at layer 4. But if you look at it from TCP standpoint, it's the above layer. So yes, I mean, that's why there is an architecture discussion.
Yes, for me, it's not really clear what you call a proxy. If you mean that when you receive something, you do fragmentation on one side and you send something on the other side, or is just to just do a SCHC fragmentation without compression?
Well, I think that was Alex's point earlier. I mean, you could do everything. The idea, if of this particular document, is to receive slowly percolated fragments until you get enough to reconstruct an IP CoAP packet. And at that point, pass the IP CoAP packet to layer 4 above to the typical CoAP proxy function. And then on the other side, you might translate CoAP onto HTTP and fly. So on the right, if you like, on the internet side, could be HTTP over IP, classical, I mean, or quick. But on the SCHC side, it would be the fragments being terminated, and if there is compression, you would also terminate the compression as an option. And that's why the SCHC gateway is the beginning of that. You can have a SCHC gateway that just does the fragmentation, then a bit later in the stack or in a different box, complete the IP and so do the first.
Because you,
What
yes, but for me it's regular SCHC. It's not something new. If you don't send anything new, Anna make a comment about what we call action in the OM draft that has been removed. We have the ping proxy, and the ping proxy was to say to the compressor, don't send the compressed packet, but instead answer directly. And I think we did never study that, but it can be also useful for any keep alive messages that you have on a protocol. You can avoid this, and then you put some condition to answer. For example, the
or you can
device.
make the two keep alive asynchronous to one another. So
Yeah.
if you add a sign of life in the last 24 hours, then you respond positively to the keep alive from the management.
So that's something. But the other thing that's now in the internet, everything is encrypted, so it's very difficult to ensure these proxy functions. So, but it's something we have to study.
So
I mean, in the SCHC coab document, there is certainly some objects inside the coab packet which are encrypted, but then there is still some coab piece which is just compressed. And if you have a stratum that does only the secure piece, you could have another stratum that does the unsecured piece and expand it towards the internet side if you really wanted to. And the compressed piece might not be well. I'm sorry, the signed the secured piece, the encrypted piece, might not be compressed. It depends on how you build your packet. So, for instance, if it's just a small data that is encrypted, maybe that one is not.
So, Pascal, I find the topic really interesting, and it's really like we had a lot of topics right away, like encryption, the
Raising
ping,
awareness, I'm good.
raising awareness. So, would you like sending an email on the mailing list saying, "Hey, how do you feel about that?" What are the next steps?
Oh, the next step for me is have a new section in the architecture. The concept of proxy is not new. What is needed to build this proxy is not new, as Laurent said, but it's not described in the architecture. That's my point. I'm not asking a new document for the proxy or anything. But yes, have an architecture. Part of the architecture document would be discussion on proxies.
Okay, so Laurent, just 1 second.
Yes, just I agree to put proxy in the architecture. It's why we remove it from the IOM draft. It's not because we think it's something bad, but it has to be more documented and to be specified. But maybe it's not the same proxying function that you have in
It
mind.
just depends on what layer and what functionality you're playing, right? If you really do it at the application layer where you handle the logic of liveness, so it's a layer 5 proxy, and yes, it's still a proxy, but the architecture should say, hey, at layer 3 with the SCHC gateway, we are proxying this, like terminating compression fragmentation. At layer 4, we transform a transport, we start a new transport on the other side, like we go over TCP on the right, but that was not TCP on the left. And then coap UDP, etc. But the architecture should show that and maybe give names to those variation of proxy. And the one you talked about for Keep Alive is pretty much at the highest layer level. It's a layer 5 proxy.
So okay, because we are like a little bit we're a little bit behind the clock. What I would suggest is that we get this to the mailing list anyway, and then we see probably there is some part that will go in the architecture draft, but maybe there is some interest for this to have a separate document. I don't know, like it seems like a very interesting topic to standardize, and where it goes, it's not clear yet to me. So if you want, Pascal, I can send an email, or you can send it. Just tell me, to start discussion. And with this, we can move on to the deep space BOF and SCHC. So, Laurent, okay, so Eric is going to leave us in a couple of minutes. So thank you, Eric, for being here. And yes, we can read the minutes afterwards. So yes, Laurent.
Yes, I will say a few words because maybe Mark can talk more about that. But we had the site meeting in Vancouver where I presented SCHC, and I made some parallels between what we do in LP1 networks, where we have some enemy like the downlink or these kind of things, because it's very expensive. And for my understanding of deep space communication is that the RTT is also the enemy, because if you send a message to Mars, I think it's between 4 and 20 minutes. So it's something we have some things in common. We had also some old studies about SCHC that say that it was good also for satellite communications, because we still keep the datagram concept. And if we lose one SCHC packet, we don't lose the synchronization of context. And so we are is very, very efficient. So I made this kind of presentation. And since Vancouver, the side meeting will be transformed into a BOF in the next in Dublin. And so my question is, can we work together on that? Is there a possibility, for example, to put SCHC with Quick? So and how we can improve the good put of the link and reduce maybe the overhead, because I suppose that when we have communication to Mars or to the moon, then it's most important thing is the bandwidth. So how we can adapt this SCHC in this end-to-end communication, and I think it goes well in the idea that we have to generalize SCHC to other environment than LP1s.
Okay, thank you. That's a really interesting topic. And Mark, do you want to add something to what Laurent said about the BOF, and how do you see it? Like, do you think that there will be a BOF? I mean, maybe it's not clear yet. I'm not sure. And oh, okay, you're yes.
Okay, sorry.
Yeah.
Yeah, Medeco UI is always kind of a.
Yes.
What do you want me to say? Do you want me to describe a bit our kind of use case so that people are kind of more aware of what we're working on, or are you so?
Yes,
Tell me what you want me to say.
Yes, please. A little bit more about the use case you're addressing. Yes.
Okay, so we're working on deep space. We're using Mars as the benchmark, but the first implementation will be Moon. As you may know, everybody is going to Moon. Deep space has very multiple characteristics, but the main two is long delays. So, for example, Mars is 5 to 45 minutes round trip time, and interruptions of communications, because, for example, you can see an orbiter going around Mars that will be behind Mars, so you won't be able to talk to it from Earth, but you would be able to talk to a rover which is on Mars, and then it comes back. Therefore, you will be having, and that's a key thing in space, is that most communications are pretty planned and known in advance, but then the view of the RTT from the transport would be, for example, maybe 20 minutes, and then oops, when the orbiter goes off the line of sight, then it becomes like 6 hours. Typical orbiter around Mars will have an orbit of 6 hours and 15 minutes communication window. So, and we actually have limited bandwidth in deep space. So SCHC is a good. In terms of context, there was an assessment done 25 years ago and the conclusion was that IP was not suitable. And remember that 25 years ago we were working with TCP and chatty protocols. So at that time, a new networking stack was started to be engineered, and it was first in the RTF, now in the IETF. It's called Bundled Protocol under the DTN working group. But this is actually a completely new networking stack from scratch. So you have to re-engineer, reinvent neighbor discovery, network security, routing, transport. Everything has to be reinvented. Still work to be done. Let's say that way. A few people with me, we did a reassessment and found that actually IP is usable in deep space if you do it right. Space agencies and private sector are keen about this, and obviously, as I said, Moon is the first target, but we're making sure that the architecture of the solution actually works for Mars, but we will be applying to Moon first. Moon is actually a few seconds away, which means that, with just a few of, slight modifications, you can make most of our protocol work. But the problem is until you have a full constellation of satellites like Starlink on Earth, then you will have the problem of interruptions of communications because of the orbiters, right? So you need something that works under interruptions of communications. And even if Laurent said the enemy is long delays, at least, overall the architecture of the enemy is actually more in the interruptions of communications in terms of the overall IP stack. So the architecture is essentially that within the celestial bodies, so Moon, Mars, or else, this will be a connected environment. So 3GPP, 3, 4, 5, 6G, and 802, whatever, Ethernet, Wi-Fi, on the surface and orbit, all IP. And then the remaining is deep space links. And that came into SCHC. Deep space links are point-to-point links. So I was planning to use robust header compression, but then Laura told me, no, this is not good, SCHC is better. So therefore, Laura presented SCHC at our last side meeting. We had side meetings since a year now. And obviously, in terms of transport, what we're using is UDP and QUIC. Obviously QUIC runs over UDP, but we can use, standard UDP protocols if they were appropriately well configured, and CoAP. And I saw Carlos here in the meeting. Carlos also provided a presentation about using CoAP in space. So a key output here in terms of working group working together is if, deep space become a working group, is the fact that we would need a SCHC profile for QUIC. I'm not sure how much you would be able to do with QUIC given it's all encrypted, but that's your business. But at least a SCHC profile for UDP would be useful. At least my, non-competent view of header compression. We had side meetings since a year now. About the last one, about 50 people were attending. Again, Laurent presented SCHC last time, Carles also for CoAP. We have a mailing list and a website, and what we have done with the guidance, let me give you the URL, and with the sponsorship of Eric Vink, we are asking for a buff request, a working group forming buff at the next IETF, and we will have various presentations from key people involved in space for to convince people that we need a working group. So that I don't know what else you want me to discuss. So I'll answer questions, I guess.
Yes, no, that's perfect. That's exactly, that's perfect. Thank you very much. Thank you, Mark. So it's really interesting, and yes, I mean when you're talking about the communications to Mars, it seems like okay, well, we'll need to figure this out, but to the moon, it seems like really like very very specific. And I'm thinking that's probably some, like we're talking about proxies, we're talking about right now about communications prone. What was the name of the draft? Prone to disrupt. What was the name? Like the networks prone to
Yes.
disruptions.
Yes.
It's exactly the topics we're looking at right now, right? So probably it goes a little bit beyond the pure compression, but we are already considering in some way or other the question about the time, right? The time in timing and IP protocols and SCHC and um, how they work together, right? Um, so yeah, it seems a very interesting space where we can work. And yes, to encourage. So we'll need to include your buff in the conflicts, in the so that we would not get scheduled in the same time. Um, does anyone participating? Does anyone have any questions to Mark or to Mark, or some ideas? I So I think that we had like a really, really great presentation. Thank you, Mark. And I mean, I personally will come to your booth, and I assume it's a very, very interesting topic to address. So I'll be looking forward in participating. And thank you for being here. So if there are not, yes, if there are no more discussions on this item, I propose that we go to the next one. So we are a little bit behind time schedule, but it's okay. I mean, the things from the architecture are fewer than the 20 minutes that we have scheduled. So Pascal, you can have your time for your early reviews. So Pascal,
I can do the sharing as you like. Yeah. Can we do it? So we have moved the SCHC protocol numbers draft from the entire working group into our working group because there was little interest and progress at Interia due to the very high reliance or high need on good SCHC understanding to really work on this document. So since Bob has moved the document into SCHC, there was little progress, and we wanted to kick it off a little bit. So we asked for reviews to see where we were, what was missing, and if we were on the right track, basically. So let me go through this. So the draft is asking for three things. It's asking for an IP protocol number. It's asking for an ether type, which would come from IEEE, and it's asking for a UDP port number. And the reviews that we got in response, as I was mentioning, comes from Eric Winke, which was early AD review. And then we had Joe Touch, more interested in layer 4, I'd say, and Miria reviewing this document. And I wanted to share with you about the feedback that we got and how to move forward with this. So Eric's point was mostly that yes, I mean, just first glance at the document, you realize that the discussion about the need for UDP port number is very, very light, to the point that two of the sections are plain TBD. And then Eric mentioned, and I hoped he would be here to give us more details, but he also mentions that we do not follow the INR consideration as expected. And he mentioned to look at RFC 9542 for discussion on the ether type. And I will give you some more on that. And then he was saying that the use case that we had, that was Bob's use case, was related to aviation, and that was very, very narrow use case to justify this allocation. So certainly we will need to beef that up, and we'll need feedback about many use cases. Yes, Laurent?
Yes, we have another use case that is IPsec. That also.
I mean, I just wanted to raise awareness, and then maybe as we did
okay,
for
good.
proxy, kick off discussion on the mailing list to address all those points. But it's not great point. I mean, it's not something that the author or the authors would like to address without discussion on the mailing list, and that's why I'm starting this presentation. So let's derive some use cases where we justify IEEE as allocation, IP protocol allocation, and UDP allocation. We need to not just say it's technically possible, but there are use cases to justify that. I just took a little quote in the middle of the rest of this RFC 9542 to show you a little bit what is expected. And the reason why I pulled that is there are things like, if you look at the second bullet, the protocol must include a version field, which we don't have, at a fixed offset. So it's not just that we want to get this IP protocol number, but every protocol number for which we ask must have from this document a version sequence, and that's interesting. So that's for the I'm sorry, that's for the ether type. The discussion, the RFC 9542 is all about IEEE interaction, and that's for the ether type. We need to be able to say, hey, if you're asking for an ether type that says check, basically the byte or the certain offset after that byte, you must have a version, meaning that if we take this path, we'll also have to define in the SCHC header a protocol version that we don't have, but we just add it to the SCHC header and say we compress it most of the time. I don't know, but have a way that it exists at a fixed offset, meaning at the very beginning, and that when we use it directly over Ethernet, it's not compressed. So we need to do something like that. So I just wanted to raise awareness that it's not just saying we want this value, that there are things that the protocols must have to be able to ask for the value. Obviously, that is not summarizing the whole RFC, and we'll have to look at everything in that RFC. And actually references things like RFC 7042, where, oops, I have a copy paste, I didn't work, sorry for that, where we actually have an example of Ethernet protocol assignment request, and you'll find that there are sections for ANR, and there is also a section for the I forgot the acronym, but the equivalent of the IEEE. There needs to be a section for IEEE as well. So this 7042 is a good example of that. Now, basically, we see that the whole how do we get those assignments? What do we need to write in the document is not complete. We need to have a proper INS section. We need to have a proper IEEE section. And we have the documents that tells us how to do that basically tell us that the protocol itself must obey certain conditions, which we need to obey. That's pretty much what I'm gathering from Eric's review. But Eric is not with us to give us more details, sorry. Second review, Joe. Yes, we can expect from Joe more challenge and details for the transport than for ether type or even IP. His first point was we need an IP header after an uncompressed IP header to be able to ask for an internet protocol number. I think he was confused that we actually mean that for IPv6, and the next header is actually in the IPv6 header. So we need to make that clear, maybe, that what we want to do for internet protocol is have an IPv6 header, and sorry, no, that's not what I meant here. So here, yes, we are compressing the IP header. So we basically would compress everything after IP and not IP. Oh, he's right. That's me who's getting confused. Yes, when we want an internet protocol number, that's for the next header. So we'll have to discuss that, because I'm getting confused. So let's move. Laurent, yes, go ahead.
No, maybe we need a protocol number to indicate that we have a SCHC content, and then that's why we need the stratum header now, is to swap this value that says SCHC by something that will be the uncompressed protocol number.
Yeah, I'm out of my confusion. Yes, sorry. Yes, you're correct. And yes, we would have, as I was starting to say, we have an IP header, which maybe was compressed by the previous stratum. And the next header in this IP header means SCHC. And then basically that means that we have a stratum that transforms this next header SCHC into maybe a next header UDP or something like that. And then the value will go away when we uncompress. But at some point of time, the IP packet looks like I've got IP next header SCHC, and everything after the IP header maybe is all scrambled, is all SCHC stuff. So yes, the confusion in this sentence was there would be one IP header that is not compressed, correct, unless it was compressed by a previous stratum, followed by another that is no. After that, it's not an IP header, unless we do IP in IP, which is possible, but it could be UDP, for instance. But for now, at the point when, as this packet flows from maybe one stratum to the next, the IP header was uncompressed, the next header is SCHC, and right after the IP header, it's SCHC data to be uncompressed maybe into UDP. So yeah, so this piece I can understand him. I can answer him. That is not necessarily next IP header. The one that's compressed is IP or anything else, depending what you have IP and IP. So ether types, it was not really challenging, or it's not his world, and he won't help us that much. Now he's more into a transport, and now it's really challenging why we would use a transport or a port at the transport level to say SCHC. He says typically it's not what you do. You negotiate. You have an application for negotiation, and then once you have negotiated, you assign this port for SCHC dynamically or something. And clearly that's not what we do. We wanted something like port 20 or 21 and all those things, some fixed value. So from his words, it's highly unfashionable. So what I'm reading from his review is, if we really want a UDP port, then we really need a use case that justifies locking a UDP port for us. Okay, so obviously his review is much longer, and this particular point is much more detailed in his email. So we have to go back into the email and start discussing the answering or discussing with him. But the point, what I'm trying to make is, first, let's have a use case that validates the needs for UDP. It's not just, oh, we can do it, but yes, we need it. And probably that particular case is when you have UDP, which is uncompressed, flying as a UDP packet, and then what is in UDP is SCHC, but you want to signal that. Now, the reason that we give in the draft for doing this is that we want to go through firewalls. And in his answer, Joe tells us that's not the recommended way to go through firewalls. Okay, so we basically need to find a better justification than just go through firewalls. And then Miria's review. Miria's first point is, why don't we do this inside the SCHC architecture? My personal answer is, well, because we want this quickly and we want to be able to have an assigned value, but the SCHC architecture itself is a long-term document, and which basically will only complete when we complete this working group. And we don't want to block the adoption of, getting these numbers till we get the architecture through. Another argument is the architecture was not supposed to be standard track, and we wanted this as a standard track. As a side effect, Birja wants that this draft has SCHC architecture as normative reference. If we do that, same problem, we delay publishing this document and asking numbers till SCHC architecture itself is RFC. Now, we could probably ask for early assignment for the IETF numbers, not sure, but from the IEEE, it would be even more difficult. So, I mean, tying this and the architecture like Miria wants seems very problematic to me. Now, if it's needed, then yes, let's move on with the architecture very quickly. Alexander?
Yeah, no, I agree with you on your analysis that probably we should try to keep it here, and argument better, like answer better on the questions about, okay, why this and why that, on the justification.
Yeah, and again, sorry that Eric had to leave, because maybe you would have given us some clues now to whether we can and how to fight at this particular point. But yes, it goes over. It's opposite to what we wanted to do so far. And then again, she complains that the use case is not. She's the one who said that the firewall traversal is a bad use case. Okay, I thought it was Joe. But yes, the use case for UDP is not very good. So we have to answer that question. Do we have a case for using UDP? When do we do that? Yes, it's not for firewall traversal, so why is it? Maybe because we do strata, and maybe the layer that can uncompress UDP is not, or the strata that uncompresses UDP is not the strata that understands and uncompresses the datagram. Maybe you can uncompress UDP in some strata regardless of what is over UDP inside the UDP datagram, which could be different things. And then depending on where the packet goes, the right uncompression can take place. And maybe that's the argument, that uncompressing UDP with SCHC is very generic. Uncompressing the UDP content might be done by different devices at different places, and that's more specific. But that could be a reason.
Yes, so here, just on the part about firewall traversal, I find this use case interesting, right? I mean, imagine that you have like a known SCHC header. So if you have a known UDP port, then the firewall can inspect the SCHC header and can make a firewalling decision based on that. And if you have just random UDP port, then you don't know that it's actually a SCHC, so the firewall cannot inspect it, right? So maybe that could be like an argument, but it will probably require like fixing the SCHC header for that specific UDP port, so that you can actually go and inspect it, right? If it's super dynamic and it changes for every SCHC instance, well, the firewall cannot inspect it. but or it needs to keep a state, right? It needs to keep a state.
Well, the idea could have been, when you go over UDP, that you have a SCHC protocol on which you basically ask the other party to start a SCHC session with you, a SCHC instance with you. And then in that piece, we negotiate the ports on both sides that will be used, or if you do it over Ethernet, that would be the SAPs, on which we are actually doing this instance. So a hard-coded value like 21 to be able to negotiate the pair of ports, to ask for the creation of the instance and negotiate the pair of ports, and then use a pair of ports.
Okay, so maybe then we can have like a standard. We can say that, okay, there is like a SCHC header that is fixed SCHC header, and like this is the face of the SCHC header that goes over UDP port blah, and you can use this one to negotiate a SCHC session on a different UDP port. But maybe you can say, I don't need to negotiate anything. I'm just going to use this standard SCHC header format, and then I'm just going to keep using this port.
Well, let's have this discussion, but it's linked to the architecture, certainly. So that justifies, quote unquote, the point that Maria makes about having a strong tie between the architecture and the port number allocation, because basically in this case the architecture is part of the justification why we do need the UDP port number. But Joe's point is how we use it, and that's why I come with these words around this. You need to look at what's done in security, that basically you negotiate the ports dynamically, and yeah.
Well, just one thing. Like at some point, I think that the architecture is going to, it's the way I feel it. It's becoming like a huge document that tries to answer everything. So probably we don't need to say to solve everything in the architectural draft, right?
But we need to position things and give them names.
Position
like
things, and then
position proxy earlier. Yeah.
Yes, and then in the SCHC protocols numbers actually provide like additional information, but probably just position things in the architecture.
Yeah, the architecture should not have the use cases, certainly. Yes. Now, it appears that this particular discussion, the document, the port number, needs more discussion on what SCHC is. That was probably coming from Joe, and better use cases discussion as well.
Okay.
But the impact on the architecture is, we need to have to expose, at least for ether types, we need to expose the protocol version, meaning that yes, in the SCHC header now there is a protocol version, good to go. And now we have this discussion on how the ports are operated. Oh, that's not how we thought they would be, but maybe we need to rethink that. To pass Joe, I mean, pass Joe's review.
That gives input on what to be.
So yes, that was very useful input on both from all parties.
Yes. So just one point, Pascal, because we are almost at the end of our slot. So we're going to continue with the architecture next time. So we'll not have time for this discussion. Do you have anything to add?
Yes, I have to add that I'm sorry I won't be there at the next two meetings. I'll be in PTO. And so I'm coming back in a few weeks, but my PTO will cover the next two interims.
Yes, don't worry. You will find the working group in a better shape than it is today, and all the documents will be progressed, and we'll not suddenly turn around and do something completely.
We'll do so much that it will take weeks to catch up.
Yes, yes. Yes. So okay, well, thank you, Pascal, for this presentation. Thanks everyone for being here, and yes, so we'll bring some of the topics that we discussed here on the mailing list, and don't hesitate, to mail if you have thoughts on any of the topics. And a huge thanks to Marco for the huge note taking he did today.
Okay, thank you all. Goodbye. See you in a month or so.
Yes, and to everyone, see you in 2 weeks. Yes.
Bye-bye.
Thanks. Bye, Carlos. Thank you, Marco. Thank you.
Goodbye and goodbye, Pascal. Enjoy.